Okay, let's unpack this. You know that feeling when you're trying to quickly grasp the essential tools,
Yeah,
especially in cloud computing, tools that, keep our online world running smoothly. Today, we're cutting through some of that noise,
that's right. Our deep dive today is into some really fundamental Azure networking services. We're talking traffic management,
right?
specifically Azure Load Balancer, Application Gateway, and Traffic Manager. These are just crucial for making applications scalable, highly available, and secure for you.
Absolutely. Think of it like understanding the different kinds of traffic cops for your cloud applications. We want to explore what each one does, its unique thing, why it exists, and how it solves real-world problems. So maybe start there. What are the main challenges these services actually fix?
Fundamentally, they get rid of common headaches. Things like uneven traffic distribution hitting your servers,
Yeah.
single points of failure where if one thing goes down, everything goes down. And also the complexity of reaching users globally with, decent speed, low latency. Before these kinds of solutions, applications often struggle with just basic reliability and performance. These services really change the game, making things robust.
Right, taking that vulnerability and turning it into resilience. And it's fascinating how they do it at different levels, different layers almost.
Exactly.
Let's start with Azure Load Balancer.
Yeah.
What's its core job? Where does it sit?
Okay, so Load Balancer operates at layer 4. That's the transport layer. It's dealing with raw TCP and UDP traffic.
Raw network packets, basically,
Pretty much. Its strengths is high volume, highly available traffic distribution, but within a single Azure region. That's key.
within one region.
Right. It spreads requests evenly across your backend pool VMs, usually stopping any one server getting slammed.
Yeah.
And critically, it uses health probes. It checks if the servers are actually healthy before sending traffic their way.
Makes sense. Don't
Good.
send traffic to a dead end.
Yeah.
I've heard stories about misconfigured probes causing big problems.
Oh, absolutely. It's a simple setting, but vital. So Load Balancer handles that raw flow regionally.
But what if you need more smarts? Like looking inside the request itself.
That's where Application Gateway steps in. It's layer 7, the application layer. It understands HTTPS traffic.
So it speaks web. What's that?
Exactly. Because it understands the web protocols, it can do advanced routing based on URLs, paths within the URL, that kind of thing.
Which is super useful for microservices, right? Sending AP orders one place, AP orders somewhere else.
Precisely. And it brings security features to the edge, too.
Right.
SSL termination, offloading that encryption work, and importantly, a web application firewall, the double F.
The WA.
Right.
Protecting against common web attacks.
Yep. SQL injection, cross-site scripting, all those usual suspects. Plus, it can auto-scale to handle sudden traffic surges. Very handy.
Okay, so load balancer for regional layer 4, app gateway for regional layer 7, intelligence and security. How do we handle like a truly global audience, users everywhere?
For that global reach, you bring in Traffic Manager. This one's different. It works at the DNS level.
DNS, so before the connection even really starts.
Pretty much. It directs the user's browser through DNS to the best endpoint for them. That could be the closest Azure region, the best performing one.
Based on rules you set.
Exactly. Using policies like performance routing for speed or geographic routing based on location, it can even point to non-Azure endpoints if needed. It's about reducing latency and boosting availability for users all over the world.
It's really clear how they each have their niche, but they sound like they could work together really well too.
Oh, definitely. They're very complementary. You often layer them. You might use Traffic Manager first for that global direction.
I send the user to the nearest region.
Then, once the traffic hits that region, an application gateway takes over. It provides the WAF, maybe routes to specific microservices.
I may be behind that.
You could even have an internal load balancer distributing traffic across the actual back-end VMs for a specific service. It builds up a layered approach. Defense in depth, distribution in depth.
Makes sense. So for someone building on Azure using these, what are the absolute must-dos, the non-negotiables?
Okay, number 1, always configure health probes properly. Load balancer, app gateway, doesn't matter. They're essential.
Got it.
2, on application gateway, enable the WA. Seriously, the security benefit is huge. 3, use auto-scaling where it makes sense. Don't get caught up by spikes.
Right. Predictable costs, better performance.
And 4th, think about deployment. Use infrastructure as code ARM templates, Bicep, Terraform, whatever. Makes things repeatable, less error-prone.
Good point. Automate.
And finally, monitor. Use Azure Monitor to see what's happening. And test. Always test in staging before you go live. always.
Great advice. So ultimately, these three, Azure Load Balancer, Application Gateway, Traffic Manager, they're really essential tools in the Azure Toolkit, each tackling different traffic challenges.
Absolutely. They work together to make sure your cloud applications are scalable, they stay up, and they're secure for your users.
And choosing the right one, or the right combination, layer 4 for Load Balancer, layer 7 for App Gateway, DNS for Traffic Manager, it's key to building solid cloud solutions.
It really is fundamental.
Which leaves us with a thought to chew on. As applications get even more distributed, think serverless, AI-driven services scattered everywhere. How will these core ideas of traffic management, these layers we've discussed, need to evolve? How do they keep pace with a world that's getting ever more connected and, frankly, more complex?